Hello world, welcome back to another tutorial. Today we're going to be talking about mouse and keyboard input. So basically, since the beginning of time, every game, or just about every game that's ever existed, has had some sort of user input. We need a way for the user to interact with the game. That's what makes a game. If you go to the carnival and your teacher's sitting up over a dunk bucket and you throw the ball at the target and they get dunked, that's user input to that game. If you play Jumanji and you're moving pieces, that's the input to the game where you become engulfed in a crazy Amazonian experience. But there's input needed in order for these things to occur. And so what we're going to do today is I'm going to implement those, show you how to use Swift to do that, and apply that to your game view. So without further ado, let's get going. Okay, so back in the code, since we don't really want to do a description of this episode, it wouldn't make much sense to do a description of this episode because you know what mouse input and key input are. We just need to know how to implement them using Swift. Let's go back to our game view in code and look at it a little bit. First things first, vertices and vertex buffer do not belong in here. I forgot to delete those. Delete them. Clean up. Code cleanup for this episode is done. Next, look down here. We have mouse input and keyboard input. So what we'll start with is what happens when you click a button. Any keyboard button that you press, there's two events that will fire. First, when you click the button down, a key down event will fire, and that's already attached to the MTK view. So let's go func key down. Now, when you release that button, there's another event that follows, and it is the key up. And for some reason, it didn't type override right here. So make sure this says override because we're overriding the function of MTK view. And then what we'll need is right now our view doesn't actually accept the first click that happens on it. And so what we need to do is we need to say accepts first responder. And that's a Boolean. We just need to return true to override that so that it does actually accept our key input on this view. So we have key down and key up. That's simple. If we were to run this right now with anything inside of it, when we press the key down, that event will fire. When we press key up, we'll fire another event. And in our case, what we want to do is we want to fire keyboard actions. So keyboard actions. So in core, I'm going to create a group and I'm going to call it input. So this will basically be our mouse input and our keyboard input or voice input or whatever type of input we want to have. Let's put it in here. So inside of input, I'm going to create a new file and I'm going to call that file keyboard. And what keyboard is it's just a static file. Public, it's just a class. Class keyboard. And what this is it will have static functions so we can turn on, turn off keyboard. And it looks a little bit like, let me just take it from over here. Here's all the functions that we're going to have inside of our keyboard class. So you'll notice that the two functions in here are public, but the property is private because we want to keep it enclosed. And what we're doing is first things first, let's just go from the top down. We have our key count. So this is how many keys that I think that are like the most amount of keys that we'll have on our keyboard. This might be more, it might be less, I don't know. But yeah, so 256 is how many keys. Then we instantiate an array using however many key counts we have, or keys in the key count we have. So keys is an array of Boolean that repeats with false. So it starts off looking like false, false. This is what the array looks like, where it just goes on for 256 times. Now, when we go down here to our first function and we set a key pressed, well, we pass in uint of 16, and this uint of 16 is attached to the key code. On our game view, if we were to just go event.keycode, it's already on there. So we'll just need to pass that through, okay? And back in keyboard, if I set key press of that key code to if it's on or off. So if we go key down, it's on. If we go key up, it's off. So inside of this array, if I do key down for whatever's at 1, we'll set it to true. And then when we do key up, we'll just set it back to false. And we can query on this array at the position down here, is key pressed at the position in here, is it on or off? So we'll return keycode.raw value. So keycode is going to be an enum that I'll show you in just a second, but that will be basically whatever value is passed up here. And we're just going to access the array at that value. So I'm just going to show you what I mean by that by creating one other file and input. I'm going to call this key codes. And then I'm going to go over here to my key codes and I'm going to copy them, and I'll show you what is up. So I didn't make this all on my own. I edited it, but I did not create it. Now I know you're thinking, I'm not typing all those. Well, you don't have to. You can go to the GitHub page, just download this key codes. I made it separate file so that you can do that. And yeah, so basically this is all the keys that are kind of relative to our game on what we'll want to do key up and key down events on. This is the hex value. And so A is 0. So if you click A, the event is 0. And this is across all platforms. But instead he's using a nice little hex value. And I'll just show you where this came from. This is this gentleman right here, Swillets, keycodes.swift. I just kind of swooped on his awesome stuff. And then I, instead of making it a struct, I took it and I turned it into an enum so that we can call the raw value, which would be a uint16. Anyway, now that we have our keyboards, this is key codes. When we call isKeyPressed, we grab the key code at key codes, so whatever this value is, and then we convert it back to an integer, and then we grab it from that index here. So that's how the keyboard works. But first we need to actually set the key press events. Let's go to our game view and do that. So all I need to do is call keyboard.setKeyPressed. We'll pass in the event.keycode is on will be true, and then we'll do this exact same thing down here. And I'm gonna say, instead of is on is true, we're just gonna say false. Okay, so let's see that in action. Let's go back to our scenes. We'll go to the sandbox scene, and instead of doing this garbage right here, let's do two things. So we'll go if keyboard.isKeyPressed. We'll do let's do right arrow. So we click down on the right arrow, so the key down event is fired. We're gonna do something, and then we'll also do something on the left with the left arrow when you click the left arrow. Okay, so we're actually doing game input now on our objects on our screen. So right now we have this huge array, this children array of players we're populating. Let's just grab the first player in our children. So I'm gonna go up here and go let child equal children. This is all the things I populated. Children at 0, so the very first one. And then when I click the right arrow, I'm gonna increase their position. So child.position.x plus equals, let's just use the delta time. And then I'm gonna copy this and I'm gonna put it down here. So if we press left arrow, we'll go to the left. Let's run this and make sure it works. Okay, so back here in our game, this right here is gonna be our first child. If I were to press the left arrow, you see he moves to the left. If I were to press the right, he moves to the right. So now you'll notice how beautiful our key input is. It's working just like it should. And then you can do up and down, whatever. You can actually recreate an entire scene, have different key input, whatever. You do you. I'm not too concerned about it. So that's how the keyboard's gonna work. I'm gonna get rid of this child stuff right here, and bada boom. That's keyboard. Keyboard's done. So back in our game view, let's do mouse. And I'm going to go above here and just put key input. Let's do 1, 2, 3, key input. What you could do really is you can go extension. So you can just copy and paste it over game view. And this is what I'll do for you right now, and copy this stuff over and go right there. And you can extend the game view a few times. So this one's gonna be the key input. We'll put that right there. Keyboard input. And then below this keyboard input, we'll do it again. We'll just do another extension. Extension on game view. And this will be mouse input. And I'm going to paste stuff over here because really, there's kind of a lot more to mouse. It's not as simple as key down, blah, blah, blah. Okay, so I'm gonna paste this right here. And this is So I've commented out the functions that we're going to make, but you see how we called keyboard here dot do things, and that's referring to this keyboard. Well, let's do the same thing with our mouse. So I'm going to go over to input first, create a new file, and call that mouse. And this will be another singleton class that has to do with our mouse. And like I said, you can instantiate these separately so you can have multiple mice plugged into the same machine. I'm not doing that. So yeah, probably a good idea. Maybe I'll do another episode on splitting out to multiple mices, but for now, no, F it. So mouse, and then we're gonna have functions here. And these functions I've also copied. Okay, I will be, so I just copied this in, and looking at it, I will have to leave a separate file for you because I don't want you to have to go through and type all this out. All right, so let's get into it. First things first is I created the same type of deal with the key codes. I did mouse button codes. So left, right, center. Yeah, pretty easy stuff. These are actually just going to be an integer because any button you click on your mouse, and when I say button, I mean any one of the buttons. You might have a game mouse. I don't have a game mouse, but that might have like 40 different buttons. So, but in my case, I just went to 12. 12 buttons, that's it. And then I made a button list just like I did with the keyboard. Basically works the exact same. As of right now, we only have these 3, but we could fill it up to 12. I have the overall mouse position, and that's going to be from 0 to the screen size. So 0 top left, 0, 0, and then the bottom right will be like 100, 100 if the screen size is 100. And then the mouse position delta will be how much it changes. Scroll position, that's your mouse scrolling, what that current position is at. So as you scroll, there's just a number that increases and decreases. The last wheel position is going to be just a way to track how much you've scrolled by. So it's like the delta wheel position, which is like these two are tied together. And yes, so let's go. Let's do this. You'll see here we have set mouse button pressed. That's going to just update the is on, just like with the keyboard, to true inside of our array. And then we'll say is mouse button pressed. Well, that's going to go into our array and see if this mouse button code is pressed. Set overall mouse position. These are mouse moved functions. So as the mouse moves, we're going to update the overall position up here to show that. So we can query on that. Then we'll do set mouse position change. So this will be the delta change in our mouse position. Scrolling of the mouse, getting window position, get D wheel. So get the delta wheel. These are kind of based off of OpenGLs, or like, so if you were to do OpenGL and use, I don't know, like any library that has viewing, they'll usually have get D wheel, get dy, and get dx. And what these do is as you move your mouse across the screen and call get, let's say get dx, if you move it to the right, it'll get that frame's distance in change. So and then it'll update the changing to 0. So it'll reset this every time you call dx. So say we start at 0 here and we move to 1, and then I call get dx, it'll return 1, set it back to 0 so that it kind of just keeps resetting like that. And then down here you see we have get mouse viewport position because screen space. So this is going to be the screen space position where 0, 0 is the center, -1 to 1 is the left and right, and -1 on the bottom and to the top. So that's going to be our screen space. Anyway, let's move on. Let's get this implemented without taking up too much of your time. So let's go back into our game view. Basically, you'll see now we have our mouse down, mouse up, right mouse down, right mouse up, other mouse down, other mouse up. And the reason this is because when we click mouse down, it's actually referring to the left mouse button click. Right mouse down will refer to the right button click, and other mouse down will be any other button on your mouse. The reason they laid it out like this, I don't know. I would rather just have one mouse down and one right mouse up, and then pass in the key code for that button. Whatever, doesn't bother me. We have event.button number, so I'm gonna uncomment this, and you'll see we have mouse.set mouse button press. We'll pass in the event.button number, just like we did the key code up here. Instead, we're gonna do button number. This is an integer, and then we're gonna set that to true. And for all of these, so for mouse up, we'll set it to false. For right mouse down, right mouse up, right mouse down, or other mouse down, other mouse up. So now we're doing the key inputs. So let's go back to our sandbox scene. We'll do kind of the same thing, except we're gonna use the mouse. So if mouse dot is mouse button pressed, and we'll do, let's say, dot left. I'm going to go ahead and press play, and we're going to fail because this isn't actually a statement. We'll go children at 0 dot position dot x plus equals delta time. So we're just going to move him to the left, or minus equals delta time. So we'll move this guy to the left, and I'll slowly click him because I can't go right. So yeah, our build succeeds. I click left, and you see he moved just a little bit as I click left. So mouse input for buttons is updated. Now that we have our updated, you can go ahead and test this if you want. I'm not gonna in this video. I've already tested it enough. But so now back in our game view, we have more. So this is just key input, mouse input. Let's do mouse moved. So I'm gonna create another extension, and I'm gonna call this mouse moved, because that's kind of different, right? So mouse moved and mouse input. So this is mouse button input, and this will be mouse moved, mouse movement. Keep these separate. So mouse movement will now take in this code. Okay, so there's a couple of dudes on here. So mouse moved, let's go ahead and uncomment the set mouse position changed. Okay, first. So what I'm doing is, if the mouse position changes, we're passing in this event that will have the new position of the mouse. I will get the location in the current location in the window of the mouse, and the change, which would be the how far it moved, and I will call mouse.set mouse position changed. That will call mouse.set mouse position changed right here and update those guys. Okay. So that's what set mouse position changed. So anytime I move my mouse, so I'm going to pass in mouse moved, mouse dragged. That one's important. Right mouse dragged and other mouse dragged. And mouse drag means you click and drag, and you haven't let up yet. It's important that we track that stuff too. But since we are tracking the button click event on or off, we don't actually need mouse dragged to do anything other than set mouse position changed. And if we want to break this out in the future, we can. If we do the scroll wheel right here, well, we can just pass in the event.delta_y on the scroll wheel, and that should tell us how much it's changed in the last frame, and then it'll set it back to 0. The last thing that I need to talk about, because it's really important, is the tracking area of our current screen. So let me uncomment it and just kind of explain this. So this is an overriding function that gets called anytime the screen is initialized or resized. And what we're doing is we're setting an area of our screen with a tracking area. We take in our bounds of the entire screen size. We're setting the options of which we want to apply the mouse. So when mouse moved, we want to do that. We want to do mouse drag, and we want it always to be active, so constantly tracking. If any one of these were off, like if mouse move was off, it wouldn't track if the mouse moved. But we actually want that, so I'm going to keep that. The owner is going to be self, and then the user info, just don't even put that. That's not important. And then we call self.add tracking area every single time this gets updated. So when we initialize the screen or when we resize the screen, this right here will update our optional values. So that's pretty cool. Let's go ahead and test it out. Back in our sandbox scene, we can call mouse.get mouse window position, and we can print it. Let's just print our mouse.get window position so you can see what the heck this is doing. But it's nice because it's a singleton. You can just call it from anywhere. You don't need to have it instantiated. So yeah, you see down here in the bottom right, we are now updating our mouse position where the top left is, well, I guess is the bottom left is 0, 0. And then the top right is going to be the max value, or I guess bottom right, whatever. Okay, you see what I'm saying. But one of the things that I wanted to do for this episode is something pretty cool. You saw it at the beginning in the intro. I want to make it so that this doesn't just use these mouse positions, it uses our screen space positions. And I've already got that built out in our mouse functions right here. So I'm going to uncomment this guy at the bottom. So get mouse viewport position will return a float too, but that's going to take in the current screen size that we are rocking with. And to use that, we need to go back to our renderer. Really, renderer shouldn't keep track of the screen size. That should be in game view, but I'm going to do it here for now anyway, just because. So up at the top, I already coded this out. Let's try to get this going as fast as possible. Oh, I guess I didn't. Okay, I lied to you. Up at the top, I'm going to create a public static var screen size. And we'll be able to call this from anywhere. And this will be a float. And I'm going to set that equal, or screen size will be a float2, which equals float2 of 0. So I'm going to instantiate it to 0, 0. This could be an NS size if we really wanted to, but I'll just do float2 for now. So screen size is going to start out at 0, 0, but every time the view is resized, we can reset this screen size to our new view size. Let's go init. So for renderer, we're going to need the init. I'm going to pass in, this won't be an override. I'm going to pass in the view that we're instantiating the renderer on. So mtk view. And then what I can do is I can go update screen size will be, let's put it down here. Public func, func, update screen size. And that will take in the view, mtk view. So we will call update screen size right here with our mtk view. Down here, we're taking in that view, and we'll just set this screen size right here. So renderer dot screen size equals to float2, but we need floats, float. And then inside here, we'll go view.bounds.width. And then we'll do inside this one, view.bounds.height. Okay? So updating screen size, every single time we resize the window, we also want to update the screen size. So update screen size, pass in the view right here. And bada boom. So we're going to set the screen size to, we need to call apparently super.init right here to make it happy. And just to make sure, oh, we'll need to pass it in this argument. So if you go back to the game view class, you see we just have this empty instantiator for renderer. Let's pass in self. So in mouse, we can call renderer.screensize.x. We can multiply that by 0.5. And then this by 0.5. So this is basically going to return the -1 to 1 value. So let's go back to our sandbox scene, and I'm going to say get mouse viewport position. And we'll return this, and this number now should be from 0 to 1, the 0, 0 being the center of the screen, and you know, the right and the left being the maximum and minimum values. So it looks like it's working just fine, like so. Now, by the way, keyboard and mouse input is done. Let's play with it. I'm gonna get rid of this update right here because we don't need it. I'm gonna turn these guys, these players, so let's go to our game objects. Let's go to player. I'm gonna make him a triangle custom. I'm gonna press play just to show you guys what's up. Now we have these really pointy triangles. Ooh, let's go back here, go to our sandbox scene. I'm gonna go let count here as an int equal 5, and then I'm gonna replace all of these 5s with count because this will make it easier for us to play in the future. Replace that 5 with count, replace this 5 with count, this 5 with count, and then these 2 right here. By the way, I figured out why the hell I did that. Because it just worked, and I was like, why does it work? And that's because the center of our object is 0, 0, plus 0.5 is going to add the last bit, so it'll center it. These also need to be floats. I don't know if that made any sense. If it made sense, comment and say it made sense. Cool. Let's press play. Everything should look exactly the same with our triangles. This is just to test to make sure we're good. Now, if we add more, so if I go 20 right here, you'll see it populates the screen with a buttload more triangles, I think. See? Cool. Look at all our triangles. You can't really see what they are, but you will in a second. There's a reason for my madness. So I'm going to go back to 5 real quick, and then I am going to go into the player class. And when we call player.update, so this is going to be like the AI of our player, okay? We want the player to follow our mouse position. So if I press play real quick and I show you our triangles, we want this triangle right here. What the hell? This triangle. We need to call super.update. Like, what the hell is this triangle doing? There's like so many triangles just behind that triangle. That was ridiculous. But if we call super.update on the triangle, I want this point to follow my mouse, right? Like, we want all these to rotate and point in the direction of my mouse. And to do that, I have discovered a nice little formula that you guys are going to think is pretty cool. So up in player.update, just do this. Just do this. All right. Use the arctan. So do the inverse arctan of mouse.getViewportPosition.x minus position.y, and then mouse.getViewportPosition.y minus position.y. So this is going to return the arctan of a number, and this is math, and I don't really understand it. I found this online a while back, and I've always kind of just played with it because it's cool. But if we press play, here's where we have user input. You'll see the triangles just kind of follow my mouse. Ooh, try to, you can, if you click, maybe they all fire a bullet at you, and you use some trig to determine like the up angle or the rise over run of that bullet and update the position as so. Pretty cool stuff. This is just, now that we've applied this logic directly on the player class, and this really isn't a player, these are more like enemies or guards or something in a room. You'll see this is sort of AI. This is like the first artificial intelligence that we've created. We want it to know where our mouse position is at all times, and we can move around. Now, to make this really cool, I was playing with this before we got in here. Let's go to our our sandbox scene, and let's set this number right here to 25. So this kind of takes away the AI and just adds a cool visual effect. So you'll see now that this is a red, green, and blue triangle, but as you move it around, just kind of look at it update. Let's see how fast we're rendering right now, because this probably is hitting my system. Yeah, so we're 60 frames per second. They're updating. It looks beautiful. That is some cool stuff. I'm going to set this back to, let's do 5, just because it looks a little bit more natural and you can understand what's going on. But yeah, hope you guys enjoyed the mouse/keyboard input episode. If you liked it and you got my code and you're digging it, following along with the series, go ahead and subscribe or like this video. Make a comment that says some cool stuff, because this is pretty cool. We actually have a game. This is like the definition of game. Input to a system equals game. So yeah, hope you guys enjoyed that. See you next time.